If you have ever done a Spring Boot tutorial, you will probably have come across Spring Initializr that you can see on the screen right now. Almost all such tutorials recommend it, and that makes sense. It is, after all, the one-stop shop for initializing your Spring Boot projects, and it can be a huge time saver. But what about all these metadata here? Your tutor might tell you what values to stick in there, or you might just leave the default values untouched for your demo. But nobody ever tells us the point of all these metadata items. And I hate that. I need to understand things from first principles, not just learn things parrot fashion. So in this video, let's understand what Spring Initializr is, how to use it, and how all of those metadata values actually translate into your project structure. Spring Initializr is essentially a project generator for Spring Boot applications. You can think of it as a jumpstart for your Spring projects, giving you the perfect foundation to build upon. You can access it at start.spring.io, as you can see here, and this is what it looks like when you first load the page up. So instead of spending time setting up the basic structure and configuring your build tool and adding dependencies manually, Spring Initializr generates all of that for you with just a few clicks. It creates a complete project structure, a properly configured build file, that could be Maven or Gradle. It creates the essential Spring Boot application class and all of the dependencies that you need. So this means that you can focus on writing the actual application code rather than dealing with setup, configuration, and pesky boilerplate code. Using Spring Initializr is pretty straightforward. So first you choose your project settings in the left-hand panel. So things like the build tool, the language, you define the Spring Boot version that you want to use. Then you define your project metadata, this section here, which we're going to explore in a bit more detail in a moment. And don't forget the section down at the bottom where we define how the compiled code will be packaged. Will it be a jar or a war, and which Java version do you want to use? Then you select your dependencies, and there are lots to choose from. We'll look at some of the more common ones in a moment. And finally, you hit the generate button to download a zip file containing your project. Then you extract the zip file, open it in your IDE of choice, and you're ready to start building. We're going to run through an actual example in a moment, but first let's break down those project metadata fields, because this, in my experience, is where we need a bit of clarity. So let's focus on this middle section here, the project metadata. So this section might seem like just a bunch of meaningless fields to fill in when you first look at it, but these values actually determine your entire project structure, and they do have an important role to play. So let me explain each one. Let's start with group. So this is typically a reversed domain name that represents the organization. So the pre-completed value that you see when you first load the page, com.example, is what you would use if, for example, your domain name were example.com. Now, I personally use dev.singlehanded because my domain is singlehanded.dev. So let's change it to that. Okay, as you've just seen, by default, the value that we set in group becomes the first part of the package name. See how it's changed what was there before to dev.singlehanded. We're going to look at the package name in a few minutes, but for now it's enough to know that you don't have to stick with the default that's provided to you here. Now, another place that group is used is in the build file. So if you're using Maven, that would be your pom.xml file, or if you're using Gradle, it would be build.gradle. So in that file, the package name is used to populate the group ID field. So that's enough for group. What about artifact? Well, artifact defines your project name in the build system. And the best practice generally is to use lowercase with hyphens. So let's change this to something specific. Let's call it tutorial demo app. Okay, so the artifact becomes another part of your package name. So you can see down here that it's tagged onto the end of dev.singlehanded, which was the group that we just put in a moment ago. Again, remember this package name can be changed. You're not stuck with the default that you're presented with here. Another thing about Artifact is that it becomes the name of your project's main directory, and it becomes part of your final compiled jar or war file name. So there it's combined with the version, which is a field in the build file, and we'll see an example of that in a few minutes. So moving on to name. Now by default, the value that you chose for Artifact also becomes the name. As you can see, it's been pre-filled in for me here, but you can change it to be something more descriptive if you want to. So let's change it to, instead of being a hyphenated word, let's have two separate words with capital letters because it looks nicer. It's more human readable. So what is name used for? Well, the main application name is generated from the value here by converting it to Pascal case and appending the word application. So Pascal case means the initial characters of each word are capitalized and spaces are removed, and also dashes are removed. So in this example here, tutorial demo would become the class name tutorial demo application. So because of the way that Pascal case works in this example, it removes spaces and dashes. It doesn't actually matter whether we call this tutorial demo the way that we've got here, or whether we call it tutorial demo in lowercase with dashes. So tutorial demo, that would actually generate exactly the same application class name, tutorial demo application. Let's go back to what we had before. So tutorial demo is our application name. So if tutorial-demo in lowercase or tutorial demo the way it is here generates the same application class name, why do we care about the way it's formatted? Well, it does make a difference, and I'll admit it is a small difference, but in the name field in your build file, so pom.xml for example, the value that you put in here is used for that name field with exactly the same formatting. So it's a small thing, but bear that in mind when you're defining your name. As an aside, if I'd chosen tutorial demo app for this name, so the same as Artifact without the dashes, then that would generate the class name tutorial demo app application, which is a bit of a mouthful. So just be a little bit circumspect with your naming here to avoid cumbersome application names like that. Moving on to description. This is simply a human readable description of your project that gets included in your build file description field. So let's call this YouTube tutorial demo project. Okay, so that's it for description. Now we get to package name, which is probably the most important field in the metadata. So by default, as you can see, this is a combination of your group and artifact values, but you can customize it if you want to. Now, the way that you define your package name is important because it determines your base Java package structure. So that's the folder structure in source main Java and source test Java, and it determines the number of levels in that structure. So by way of example, just have a look at these images that I've got of some folder structures. A package name of dev.singlehanded.tutorialdemo_app, so the same as we have here, that would generate this folder structure that we see on the left. So we have source, main, Java, dev, single-handed, separate directories until we get to tutorial demo app. Now, if the package name was simply tutorial demo app without dev.singlehanded as a prefix, then this is the folder structure that we get. We get 4 fewer directories. We just go straight from source, main Java into tutorial demo app. Now, if you use an IDE, like IntelliJ, for example, this really isn't an issue. The number of folders in your structure isn't really not an issue because your IDE knows which is the base package directory and it will cater for whatever the setup is. But if you need to navigate around the projects in the terminal, then having a shallower structure could be an advantage. But for the purposes of this demo, let's flick back to where we were. I'm just going to stick with the default dev.singlehanded.tutorialdemoapp. Okay, let's see how those values translate into an actual project structure with a concrete example. So these are the values that we've just created. So if I click generate, it downloads the project as a zip file. Now if I go to the terminal, just switch to the downloads folder, and you can see there's our tutorial demo app zip file. So if I unzip that, We can see all of the structure that was within that zip file. And I'm going to use the tree utility to open up this directory tree. So that's a super useful little utility. And in the description below, I'll include details of how you can install it in your terminal if you don't already have it. So let's have a look at the directory structure. So as you can see, our package structure is top level tutorial demo app. Then we have source, main, Java, dev, single-handed, and then tutorial demo app with underscores. Now that's because Java package names can't contain dashes. And we can see here that our main application class is called tutorial demo application.java. And we can take a peek inside our pom.xml file, which is, you can see that's in the top level there. So let's have a look inside there. So this is the contents of the pom.xml file. Let's highlight all of this. So these are the values that we've just put into the metadata fields. So the group ID is dev.singlehanded, the artifact ID tutorial demo app. This is the version that's automatically generated, and the name is tutorial demo, which we just defined, and the description YouTube tutorial demo project. So those are all of the values that we just defined in the project metadata. One extra feature to note is that Spring Initializr includes the Maven wrapper or the Gradle wrapper if you selected Gradle in your generated project. So if we scroll up to here, we can see there we've got the Maven wrapper in the top level. So this means that you don't need to have Maven installed on your system. You can just run it from within the project. So that's helpful if you've got different people working on the project. You don't need to keep build tool versions in line across different machines because everybody can use the same version within the project. It makes your project more portable and easier to set up across different environments. So let's make use of this Maven wrapper to compile this project. Just remember that all we've done is define some values in Spring Initializr, download the zip file and unpackage it. And having done that, we can actually compile our application. So /mvnw, and then we'll just use the package command. Now, of course, there's no mvnw directory in the downloads folder. We need to, let's change to the actual tutorial app folder, and then we'll run the same command again. So there we go, it's compiling our jar file. Takes a little moment to run through, so there we go, build success. And if we now have a look at the contents of our tutorial demo app, you can see we have a target directory. So let's change into there, and you can see in there there's our compiled jar file with tutorial demo app, which was the artifact that we defined earlier, and there's the version that we just saw in the pom.xml file. But that was one aspect of Spring Initializr that kind of blew my mind when I first started using it. And so once extracted, the project that you've just downloaded can be compiled thanks to the Maven wrapper, as we've just seen, and run without doing anything else. Obviously what we've got here won't actually run because it's not a project that will actually do anything. So let's take a look at the dependencies section and add one and then run the app. So the first thing I'm going to do, I'm just going to change this name so that it generates a different zip file. So let's call this Dependencies demo app, and I'll leave everything else as it is. I'm not going to worry about those field names at the moment. So over in this right section is where we can select our dependencies. As you can see, there are dozens, probably hundreds of them. So the ones you choose clearly depend on the nature of your project. So you can search for specific dependencies if you know what you're looking for. So for example, if you're working on a Rabbit project, these are the relevant packages that you might want to choose. So each dependency that you select will be added to your build file, so pom.xml or build.gradle. So that saves you the trouble of looking up the correct versions and configurations and going to the central repository and all that kind of thing. So common dependency choices might include, so Lombok, for example, that minimizes boilerplate code. Might use Spring Security for authentication in your app, or Spring Data JPA, for example, if you've got a database connection. And there are loads more. Another commonly used dependency is Spring Web, and you can use that to, as it says here, build RESTful APIs, and it comes complete with a Tomcat web server. So let's add that one. So we've just got that one dependency, we've just changed the artifact name, so let's generate the project, go back to the terminal, go back up to downloads. What have we got in there? So we've got dependencies demo app, so we can unzip that. Let's just have a quick look at what's in there. So you can see that looks very similar to our previous application. And we can compile it. Let's just move into that directory first of all. So we can use the Maven wrapper again. Just package it up. Our project has built. So let's run the project. We know it's a jar. We know it's in the target directory and it would be called dependencies something. So there we go. So you can see the application started very quickly, and here we have Tomcat initialized with port 8080. So let's just whip back to the browser and let's have a look at localhost 8080. And we can see that our web server is up and running. This is what you would expect because we haven't defined any routes in our API. So this white label error page is evidence that our app is up and running. So I hope you've seen from this short tutorial that Spring Initializr is a powerful tool that streamlines the creation of Spring Boot applications, and understanding how these metadata values translate to your project structure can help you create well-organized professional projects. If you found this tutorial helpful, I would appreciate a like, and please subscribe for more software engineering tutorials. Drop any questions in the comments below, and that's it for now. See you next time.